So today we're going to focus on learning about the number plane or the Cartesian plane, and we're going to learn the basic terms around this and how to draw a Cartesian plane, and most importantly, how to plot different points on a Cartesian plane. So you may or may not have seen the number plane before or the Cartesian plane before, but we're going to start fresh, and we're going to start by saying that it's made up of the x-axis, which is your horizontal line, the y-axis, which is your vertical line, and altogether it looks like this. As you can see, it's broken up into 4 parts, okay, and you kind of need to know these names. The first one is quadrant 1, which is in the top right, and then we go around in a circle anti-clockwise. Quadrant 2, quadrant 3, and quadrant 4. So all we're really looking at so far is what these names are. So we've got the x-axis, the y-axis, and the 4 quadrants, each which have their own special names, starting from the top right. And now we're going to focus on labeling points on a number plane or a Cartesian plane. So we do have a set of coordinate points. Okay, so for example, this point here, as you can see, is just a dot on the Cartesian plane, but it has its own little coordinate point name. So as you can see, it has an x value of 3 and a y value of 2. This means that we call this point 3, 2. Now, what's really important here to notice is that when you label a point, you should be labeling it with the format of x, y. So the x value always comes first and the y value always comes second. So let's look at another point. This point here. So you can see that it has an x value of -4 and a y value of 3. So we say -4, 3. Of course, putting the comma in the middle. Let's look at this point here. We have an x value again of -4, but we have a different y value of -3. And this one here has an x value of 1 and a y value of -2. The most important thing about this slide here is remembering to put it in x first and y second. It's also really important to know that this Cartesian plane doesn't just stop at 4 or -4. This arrow here tells you that this goes on forever. So you could have numbers as big as 1,000, a million, on this way -1,000, -1,000,000, and same for up and down. So it doesn't really stop there. This can be stretched as wide or as high as possible. And another thing probably that we should think about is the fact that quadrant 1 always has 2 positive numbers in their coordinate points, so a +3 and a +2. Quadrant 2 always has a -x value and a positive y value. Quadrant 3 always has both of them being negative, and quadrant 4 always has a positive x and a negative y. And as you can see, with the way that they label the axes, it kind of makes sense why that's the case. Another important definition that we need to know is the word origin. And the origin is pretty much just the point in the middle of the 2 axes. So right there. And this is where the point is 0, 0. Another way to call this is the center point. The reason why this is important is because we identify our coordinate points based on how many units to the left or the right of the origin, that gives us our x value, how many units up or down of the origin, and that gives us our y value. So if I was talking about the one we're talking about before, which I think was around here, okay, well, it's 3 points to the right of the origin and 2 points up. So if it's to the right, then it's a positive number, and if it's up, then it's also a positive number. And this is going to help us understand what happens when we have points on the axes. For example, here we have a point where x is -2. But what's y? Well, it's not going up or down, so it just stays as 0, right? So here we have x going left 2 to get to -2. So obviously left, which means it's a negative number. Okay, so that means that our x value of the coordinate point is -2. But what's our y value? Well, it hasn't gone up or down, so we just keep it as 0. What happens if we have a point on the y-axis, so up here? Has it gone to the left? Has it gone to the right? No, it's actually stayed in the center if we're talking left and right, but it has gone up. So that means that we have our x value as 0 and our y value as 4. And this is how we label x-axis coordinates or y-axis coordinates. So let's start with some example questions. So here it says one point is not in line with the other points. Name this point. So here we have 5 coordinate points, and I'm expecting that one of these 5 will not be in line with the rest of them. So the first thing I'm going to do is I'm just going to plot them. So for the first one, 0 and 1, my x value is 0 and my y value is 1. So that should go on the y-axis. The next one, the x value is 2 and the y value is 4. That should be going up there. The next one, 3 and 4. X is 3, y is 4. Okay, so we can see that one of these 3 would be the ones. For the fourth one, x is 1 and y is 2. Okay, and 2 and 3 goes there. So which one of these 5 points does not follow the line pattern? You can clearly see that if we remove this one here that I'm scribbling in yellow, I guess now in blue, is the one that's out of order. So that would mean that the one that has x being 2 and y being 4. So this one here is the one that is not in line with the other points. So here it's asking us to find the midpoint of a line segment that is joining these pair of points. So we've got 2 points, 1 and 2, which goes here, and 3 and 4, which goes there. Basically, what they're asking us to do is to find the point in the middle of these 2 points. So what I might do is I might put a line in there, and halfway between our 2 x values, so our 2 x values are x equals 1 and x equals 3. So that means halfway between my x values should be 2, and my 2 y values are 2 and 4. So halfway between my 2 y values should be 3. So with that being in mind, my midpoint should be right there where x equals 2 and y equals 3.